All right, on to the next topic, graphing linear inequalities. You're going to see we're going to go back to the dreaded y equals mx plus b form. Okay, when we graphed that, remember m, this was the slope, and b, this was the y-intercept. Okay, I think most of you guys, when it was in that form, it was very, very easy for you to graph. We're going to apply it now. Instead of having this as an equal sign, now we're going to replace it with an inequality symbol. It could be less than or equal to, or it could be greater than or equal to. Okay, now before we get into the graphing, let's kind of put this into perspective here. Kind of have an intro right here. I have a linear inequality, so I don't have an equal sign. I have an inequality of less than or equal to. I have y is less than or equal to 2/3 x plus 1. And out of 1, 2, and 3, it's asking us, is the ordered pair for 1, 2, and 3, is it a solution to this inequality? Okay, well, let's plug it in, and let's see if it gives us a true statement. So if I have 0, 0, I'm going to take 0, I'm going to plug it in for this x. I'm going to take this y equals 0, I'm going to plug it in for this y. So when I do that, I'm going to have 0 is less than or equal to 2/3 times 0, and then plus 1. So I still have 0 here. Well, 2/3 times 0, that's just 0. And then 0 plus 1 gives me 1. Okay, and then I ask myself, is 0 less than or equal to 1? Yes. So since that's a true statement, I say yes, 0, 0 is a solution to this inequality. Okay, let's do number 2. Number 2, now I'm going to take 2, plug it in for this y. I'm going to take this 0, plug it in for this x. So it's going to become 2 is less than or equal to 2/3 times 0, and then plus 1. So 2 is less than or equal to, again, 2/3 times 0 is 0, and 0 plus 1 is 1. Okay, then I have a number on each side, then I ask myself, is 2 less than or equal to 1? Well, 2 is not less than 1, so I say no, that's not a solution. Okay, and if I do number 3, okay, I want to do the same process. This 5 is the y value, so I plug it in there. This 0 is the x value, so I plug it into there. So I have 5 is less than or equal to 2/3 times x, which is 0, and then plus 1. So 5 is less than or equal to, again, 2/3 times 0 is 0, and 0 plus 1 is 1. And that is a false statement. 5 is not less than or equal to 1, so I say no. Now, why are we doing this? You're going to see when we graph, we're going to graph the line, and we're either going to shade above or below the line. Kind of like when we shaded before, but it was just like one real number line. Here we're shading within the coordinate plane, the x and the y-axis. What this means is this 0, 0, since it's yes, this should be in the shaded region. Okay, now let's put it together. Now I'm going to look at number 1. Okay, number 1, if I graph the linear inequality, first I have to make sure if it's in slope-intercept form. And in this case it is. So I'm going to put m is the 2/3. The y-intercept, or b, is this. It's the 1. Now I'm going to graph this. It's the same thing we did for this intro. I'm going to make a connection between 1, 2, and 3 and with the graph for number 4. So if this is my y-intercept of 1, I start on the y-axis at 1. A lot of you guys on the midterm kept making this your x-intercept. Remember, b is the y-intercept, so I start here. I'm going to put a dot right there. Okay, then our slope is 2/3, so rise over run. From here, I'm going to go up 1, 2, to the right, 1, 2, 3. So right there at that arrow, that's where we're going to get a point. Right here. Okay, I'm going to connect it, and I have my line. Now, since I have an inequality symbol, okay, this is less than or equal to. So less than or equal to, that means everything below the line that I just drew, I'm going to shade in. It's going to be a solution. So I'm going to use a different color. I'm going to shade it in red, just so we see this. Okay, everything here is a solution to this linear inequality. Now, let's make sense of this. Let's look back to number 1, 2, and 3. Right? I said 0, 0. This was, yes, it was a solution. And look, 0, 0 is right here. That's in the red shaded region. 0, 2, this was no. Well, if I look at 0, 2, 0, 2 is right here. See it? That's not in the shaded region. That makes sense. The other point, 0, 5, well, 1, 2, 3, 4. Here's 0, 5. See how it's not in the shaded region, the red shaded region? That's why we got no. Now, what we can kind of use as a test, this is much easier using 0, 0, because when you plug those in, everything cancels out, and you get the answer right away. If you plug in 0, 0, and you get it to be yes, then the origin should be in the shaded region, which it is for number 1. If you get no, then that point that you tested should be in the unshaded region. Okay, let's skip down to, we're going to do 3 and 4. Now, 3 and 4 is going to require a little bit more work because it's not in slope-intercept form. So we have to get y by itself. Number 3, it's not too bad. I can just divide both sides by -2, everything by -2. I'm going to get y by itself. Oops. So I'm going to have y. Now here's the main thing to remember. A lot of students forget this. If you divide everything on both sides by a negative, you have to switch to inequality symbol. So this becomes greater than or equal to. And then 8x divided by -2 is -4x. And this -2 divided by this -2, these negatives cancel. It's going to give us +1. So using this, m is -4/1, and b is just 1. So I begin with b. This is on the y-axis, so I plot a point right there. b equals 1. Okay, my slope is -4/1. So rise over run, this means I'm going to go down 1, 2, 3, 4, and then to the right 1. So that's where I'm going to plot a point. Right here. Okay, I'm going to connect my line. And then after you connect it, the only thing that's different, just follow the inequality symbol to where you shade. So again, I'm going to shade it in red again. Now here it is. It says it's less than or equal to. So that means I'm going to shade. And it's kind of tough to say, well, what's below? Well, think of it this way. It's kind of like what's below and what's to the left of the line. So actually, you know what? It's different because it changed here. It's greater than or equal to. I'm going to shade above or to the right of the line, which is going to be this right here. All right. So everything in this shaded red region is a solution to this linear inequality. You can see the origin. I always like picking the origin. See the origin here? It's not in the shaded region. Now to check it, I'm going to plug 0 in for y and 0 in for x to check. So I'm just going to put this here, check. So if I want to plug 0, 0 in, it's going to become what? -2 times 0 is less than or equal to 8 times 0 minus 2. Well, -2 times 0, that's just 0. And then 8 times 0 is 0, and 0 minus 2 is -2. This is a false statement. 0 is not less than or equal to -2. So I say no. That's why this point 0, 0 is right here. It's not in the shaded red region. All right, you know what? I won't do number 4. We'll do that in class. But the main thing is, here, guys, if you know how to graph a line in slope-intercept form, which you should know, it was on the midterm, it's very easy. The only last thing that you do is you graph the line, and then if it's greater than or equal to or greater than, you shade above and to the right of the line, or if it's less than or equal to, you shade below and to the left of the line.